Welcome, everyone. Today, we are diving into a crucial skill for orchestrating model training, configuring experiment tracking with MFlow in Azure Machine Learning. Let's get started. Working in a Jupyter notebook lets you experiment interactively and iterate rapidly on your machine learning models. It is an incredibly powerful environment. However, this speed introduces a significant risk. If you are constantly tweaking hyperparameters, changing datasets, and rerunning cells, how do you remember what you did an hour ago? To make that experimentation meaningful, you absolutely need to track what you try. Without systematic tracking, it is incredibly easy to lose sight of which specific configuration produced which result. You might find a fantastic accuracy score, but completely forget the learning rate that got you there. By configuring experiment tracking, we eliminate this guesswork. We convert our fast-paced notebook experiments into an organized, permanent record of our scientific process, ensuring every trial is fully reproducible. Take a look at this flowchart. On the left, we start with our Jupyter notebook, the hub of our rapid iteration. Every time we execute a training run, that data flows into our experiment tracking engine in the center. Instead of just disappearing when we close the browser, this engine routes the metadata into a permanent record, ensuring reproducible science on the right. This visual perfectly captures why tracking is the critical bridge between chaotic experimentation and professional machine learning engineering. So, what exactly is the tool we use to track these experiments? We use MFlow. MFlow is an open-source library built explicitly for tracking and managing your machine learning experiments. Specifically, we utilize a component called MFlow Tracking. This component acts as a silent observer while your code runs, logging everything about the model you are currently training. It categorizes this information into three distinct pillars: parameters, metrics, and artifacts. Parameters are your inputs, things like batch size or learning rate. Metrics are your outputs, like your accuracy or your loss curve over time. Artifacts are the tangible files produced, such as the actual serialized model or generated evaluation charts. By capturing these three pillars, MFlow provides a holistic, 360-degree view of every single training attempt you make. This diagram breaks down the MFlow tracking component into its three foundational pillars. At the top, we have the core MFlow engine. It splits data collection into parameters on the left, representing your configuration inputs like learning rate. In the middle, it captures metrics, which track your model's performance, such as accuracy. On the right, it saves artifacts, which are the physical outputs like your generated model files. Visualizing it this way helps you remember exactly what kind of data you should be logging during your experiments. As you begin to train dozens or even hundreds of models, you need a way to organize them. This is where the concept of an experiment comes into play. As a data scientist, you use notebooks to execute your code, but you use experiments to group your model training results together. Think of an MFlow experiment as a dedicated folder for a specific project. If you are building a fraud detection model, you want all those specific runs grouped together, completely separate from your image classification runs. You set this up programmatically in your script before training begins. However, there is an important caveat to remember. If you don't explicitly define and create an experiment name, MFlow will catch your data, but it assumes the default experiment with the name default. Over time, dumping everything into default will create a massive, unsearchable mess, so always name your experiments. Let's follow the routing logic in this flowchart. All your training runs start on the left. The system immediately asks a vital question: did you name the experiment? If yes, the run is routed to a cleanly named experiment, like fraud detection, leading to an organized and searchable workspace. If no, the run defaults to the default experiment folder. As shown on the bottom right, relying on the default folder quickly leads to a disorganized and cluttered environment. Always take the top path. Writing code to manually log every single parameter and metric can be tedious. Thankfully, MFlow provides a powerful feature called autologging. Autologging allows you to minimize the effort needed to log the model's results, especially when you are using popular frameworks like the scikit-learn library. By placing a single line of code in flow.autolog at the top of your notebook, MFlow automatically hooks into the training framework. As your model trains, it captures the hyperparameters, the training metrics, and even the final model artifact without you writing another line of tracking code. This is incredibly powerful for rapid iteration. You can focus entirely on experimenting with the model's architecture and let MFlow silently build the comprehensive record in the background. This sequence diagram illustrates the beauty of autologging. The data scientist starts by running the autolog command in their Jupyter notebook. Then, They simply execute their standard model training step. Notice what happens next. The notebook communicates with the MFlow Autolog engine, which automatically intercepts the data. Without any further human intervention, MFlow silently sends the parameters, metrics, and final model artifact directly to the Azure ML workspace. While autologging is fantastic, it isn't magic. It only logs what the framework inherently knows about. What if your business requires tracking a highly specific financial penalty metric, or you want to log a custom-rendered matplotlib chart? That is when you must use custom logging. Custom logging involves explicitly using commands like mflow.log metric within your code. Custom logging gives you absolute, granular flexibility, but it also creates more work, as you have to manually define any parameter, metric, or artifact you want to log. You are taking full control. Often, the best strategy is a hybrid approach. You turn on autologging to capture the massive baseline of standard parameters, and then you add a few lines of custom logging to capture those unique, domain-specific insights that matter most to your stakeholders. Here we compare our two logging strategies. After starting an MFlow run, you face a choice. The left path, autologging, is broad and fast, automatically capturing standard metrics and parameters. The right path, custom logging, requires manual effort, but allows you to capture specific business KPIs and custom charts. As the arrows show, both paths ultimately converge into your centralized MFlow registry. Using both paths simultaneously gives you the ultimate tracking setup. You have spent all this time diligently logging your experiments. Now it is time for the payoff. When your training job completes, you don't need to sift through massive JSON files. You can review all logged metrics beautifully visualized in the Azure Machine Learning Studio. The Studio acts as your analytical dashboard. You can click into your specific experiment, select dozens of historical runs, and generate comparative charts instantly. Which learning rate gave the lowest loss? The chart will tell you immediately. Furthermore, because MLflow is deeply integrated, it provides a unified view. This means you can seamlessly compare your manual, custom notebook runs directly against the automated models that AutoML trained, evaluating them side by side all in one centralized place. This visual comparison is how data scientists confidently choose the absolute best model for deployment. Look at this convergence in the Azure ML Studio. On the top left, we have our custom notebook runs. On the bottom left, we have our AutoML runs. Both streams of telemetry flow seamlessly into the Azure ML Studio. The Studio acts as an equalizer, generating a visual dashboard. Here, you can compare metrics across all types of runs simultaneously, leading to the final, crucial step, selecting the best model for production. Notebooks are fantastic for the inner loop of development, the rapid experimentation phase. However, to truly harness the power of AI, we must connect this work to the broader MLOps lifecycle. You don't deploy a notebook directly to customers. Instead, you transition to automated pipelines. Why is MFlow tracking so critical here? Because when you find that perfect model in your notebook, MFlow has already saved the exact parameters, the environment dependencies, and the model artifact. You simply register that tracked MFlow model. Your automated CI/CD pipelines can then pick up that exact registered asset and deploy it safely to an endpoint. By tracking machine learning experiments and models with MFlow within Azure Machine Learning, you establish an unbroken, auditable chain of custody from your very first line of experimental code straight through to your live production systems. This diagram maps the journey from experimentation to operations. We start at the top with notebook experimentation. MFlow acts as the bridge, tracking and registering the successful model into the model registry. This registration triggers the MLOps pipeline, pulling the model through automated testing and finally deploying it to a production endpoint. Notice the feedback loop at the bottom. Continuous monitoring of that endpoint feeds right back into future notebook experimentation. Let's tie everything together with a critical real-world use case. Prosware, a healthcare startup, needs to find the absolute best diabetes classification model to assist doctors in their web application. In the medical field, manual guesswork is unacceptable. The data science team needs to rigorously test dozens of algorithms. They set up an MFlow experiment. First, they run AutoML to get a strong baseline. Then, they dive into their Jupyter notebooks, using autologging combined with custom logging to fine-tune specific neural networks. They are specifically targeting and comparing the best AUC-weighted metric to ensure the model distinguishes properly between classes. Because every single trial was tracked by MFlow, the lead engineer can pull up the Azure ML dashboard, definitively prove which model achieved the highest AUC-weighted score, and seamlessly promote that perfectly documented model into their life-saving production application. Our final diagram shows Proseware's clinical workflow. Clinical data enters the experimentation phase. The team uses a dual approach, generating baseline models via AutoML and custom-tuned models via interactive notebooks. Crucially, both paths flow directly into MLflow tracking, where the system meticulously records the AUC-weighted metric. The team simply selects the model with the highest score and deploys it directly to the health app, confident in their data-driven decision.